Ladies and gentlemen, please welcome back Herb Kunitz.
Welcome back, everyone. Hey, it's good to see after the party that we got a lot of people back. That's really good to see. So who enjoyed that party last night? Everyone have a good time? And who knew that it was actually in this room you were doing that last night, and it looks like this again, and you get to come back. So great party. Thanks, everyone, for joining. A lot of fun, the different games, all the different things last night. Some different pictures just from people having some fun last night, right? Whether it's playing foosball or you had the people in the motorcycle uniforms and the lights and all the stuff that was happening. So it was great to have everyone. Also had a lot of fun during the day yesterday with the customer panel, right? Having the different customers up, talking about what's happening. So great opportunity. We're going to continue that theme today. So as you think today, we've got a couple things that are happening, right? So we've got what we're going to call today the hoodie and suit day. And the reason for that is we're going to continue to go through on some of the great customer use cases, as we have Macy's, Comcast, and others up here talking about what they're doing. But we're also going to dive into the technology a lot deeper today. We'll have hoodie day as well. And as you go through that, we'll have a couple sections, one on the cloud, right, and how you work in a hybrid environment, what the opportunity is, and how everything works together. But the other one's going to be a great demo of the application of the technology, what you can do, what's possible. And I think what you're going to find is going to be really fun, very interesting, slightly creepy, but it's going to be a great opportunity to see what's happening with the technology and see what's possible, what you can go do with it. So enjoy the day as we go through this. We'll be back in a couple of minutes, but first what I'd like to do is bring up our first speaker, Mark Holderbaugh out of Illinois, running Yahoo's engineering team. And going to talk where we had yesterday, talked about Yahoo Mail and some of the things that are possible. Mark's going to dive deeper into the tech and say, as you think of things like platform engineering and utilization, how do you go best optimize? So Mark, thank you and welcome.
Thank you. So, hang on. Tell him it's not my slides. Good morning. Thanks, Herb. Hope everybody enjoyed the party last night and is enjoying the summit. As you said, my name is Mark Holderbaugh, and I'm the luckiest guy in the world because I get to manage the Hadoop engineering team at Yahoo. Yahoo has a long history of working with Hadoop, and today, unfortunately, I had this grand plan to hook my slides to the popular books and miniseries from Game of Thrones from George R.R. Martin, but like Book 6, that got delayed. So you're left with a normal technical talk, and I will go through it at this point. So hope you got your coffee, and let's go. As I said, Yahoo has a long history of working in Apache, Hadoop, and big data. This slide has been shown by other Yahoos throughout the years, and documents the key contributions by Yahoo, from original work to open source Hadoop, stabilizing Yarn at scale. It gives a picture of what we've done. It's also amazing how time flies. If you look at this slide, it's amazing how this technology, the ecosystem, the summit has grown over 10 years. This slide also shows kind of us trying to keep track of our footprint, our size, and how much we use Hadoop. As you can see on this slide, it shows that we're right on 35,000 heterogeneous nodes running on 17 Hadoop clusters, largest one being around 5,000 nodes, but there's smaller ones. And these clusters are pretty much behind every dollar Yahoo makes. They run advertising, they run search, and as of course yesterday you heard from Peter Monaco, they deal with mail. But that growth, especially the part where you see on the slide where the last 3 years the servers have kind of leveled off, does not convey the full picture. Even though the number of nodes has leveled off, the power of those servers has grown. And as this slide shows, in the last 3 years, the demand for compute has grown and quadrupled at Yahoo. During my brief talk today, I hope to highlight some of the areas that Yahoo has been working on to deal with that increased compute demand and also dealing with improve our utilization. The cool thing is that all these areas I'm going to highlight are actually talks at this year's summit. So I'm hoping that I'll give you enough information to want to go back and check out the talks either later today or once you get back home. The first area that I want to talk about, and I know the slide's a little busy, but I'll try and hone you in on the important parts. is dealing with yarn utilization and CPU utilization. Yarn, as the last slide showed, enables us to increase our utilization and keep up with that compute demand over the last 4 years. However, due to the way Yarn schedules and schedule on our busy clusters, we were noticing that we weren't getting all of our hardware fully utilized. These graphs are from a 2,000 node research cluster at Yahoo. It's busy every day of the year. And if you focus in on the shaded areas, that's where Yarn utilization, the black line, is reaching 100%. But if you look at the blue line, which is much lower there, it shows that we're only getting about 40% of the utilization out of the hardware that we have on this cluster. So Yahoo wanted and needed to find a way to drive up that CPU utilization. To increase that utilization, Yahoo enhanced Yarn via Yarn 5202 to do a dynamic overcommit based on feedback from the nodes. Essentially, we're overcommitting the hardware similar to the way a airline overbooks flights. And now, again, focusing on those same shaded areas, again, where Yarn utilization, the black line is towards 100%. You can see that blue line is now approaching 60 to 80% utilization. We basically squeezed, with one set of changes in Yarn, squeezed another 20% or more out of this hardware without buying new hardware, without changing the jobs running on it, basically saving us millions of dollars. A pretty neat magic trick. And these changes, I mean, pretty much work in any size cluster, but it's just very dynamic at our scale. We're in the process of rolling these changes out, and we hope to have it on all our clusters by the end in the next few months. You can check out Jason Lau's talk from Tuesday, investigating the effects of overcommitting Yarn resources for the gory details on this change. The next area I want to talk about is our migration to Tez. Tez has been well documented in the past summits on the gains that it will gain for us and the technical details, so I'm not going to go into that. But the key that Tez gives to us is it gives us, with zero minimal changes to jobs, it allows us to deal with our millions of jobs that run in Pig on Hive every day. As this slide shows, we run millions of jobs. And the slide also shows we're about 50% through with our converting of those jobs from MapReduce to Tez, and we're seeing some pretty good gains. Unlike the previous slide, the Yarn CPU utilization, it's not a dynamic knife switch on the cluster. We have to deal with migrating each individual jobs. That job mix on those clusters that our customers are doing and running changes every day, so it's not hard to get a snapshot like the previous slides of the utilization. So on this slide, I try and document one of the key examples. This is the data represented from one of our large revenue data pipelines. It's data from the past 6 months, and you can clearly see the migration Pig to Tez. You can see the reduction in runtime hours, a reduction of how much vCores we use, a reference of memory. I mean, it basically shows around a 30% gain from converting this one pipeline from MapReduce to Tez. You can get more details on our Pig to Tez migration later today by attending Rohini Palaniswami's and John Eagle's talk. Yahoo experience running Pig on Tez at scale, for more details on the fun of migrating Pig and moving to Pig on Tez. This slide is similar. We're migrating Hive jobs from Tez, but it's kind of, I want to focus on kind of a slightly different thing here. Basically, Hive not only gave us a better utilization, but also help us improve our latencies and be able to do more demand type latent jobs on these clusters. This is from a talk that was also done earlier this week, and it's one specific data mart example, and it shows that the cool thing here is that these times for these latencies are on a 4,000 node shared cluster. That cluster is up, it's running other stuff other than Hive, and we're able to get these kind of latencies out of the jobs, thus being able to avoid having a dedicated cluster or dedicated hardware just to do the Hive queries. So we basically, again, save us money by being able to deal with a multi-tenant shared cluster. Mithun Radhakrishnan and Josh Walters talked from Tuesday, Faster, 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 the true story of a mobile Linux data mart, has more information on this conversion to Hive. Final area that I want to discuss is around Apache Storm utilization. Yahoo has embraced Storm since its creation in 2012. We've gone from running like 40 node cluster back in 2012 to we're running 16 clusters with 3,500 nodes. Storm has been embraced. It's basically being used in every part of Yahoo. It's dealing with advertising data analytics. It's dealing with categorization. It's even being used to monitor these clusters I've been talking about. But as we were rolling it out and we were increasing the number of nodes that were running it, we noticed the utilization on our Storm clusters was even lower than the Hadoop clusters. So we needed to find a way to improve that utilization. But we also had to keep our fine grain stuff. As this slide shows, we went off and invested into Storm 893, which is a resource-aware scheduler. And as of Summit, we've migrated some of this is a picture from one research cluster, and it's running, you can see the timeline switch. This is a time switch. We switched from the default scheduler, which was multi-tenant, an isolated model, to the resource-aware scheduler, and you can see the utilization gains we got after that. We basically see 50% memory savings. We see room for more topologies. You can check out Jerry Ping's talk on resource-aware scheduling Storm from Wednesday on RAS. Last, hopefully I've given you a glimpse of some of the areas in which I was working to improve our scale and utilization. There's a couple other talks that are really closely related to this later this week that I didn't have time to go into. Kindle Thrap's cost of resource tracking, which kind of talks about how we put dollars behind that and give feedback to our users. And then also Savitha Ravakrishnan and Dheeraj Kapoor's talk, which is on managing Hadoop and HBase and Storm clusters, basically talks about how we manage these big clusters and use rolling upgrades to make sure the clusters stay up and thus get the most out of our hardware. Please feel free to stop by Yahoo's booth to talk to me, or better yet, the guys and gals that created this stuff. And thank you for your time today, and I hope you enjoy the rest of the summit. Thanks, Herb.
Thank you, Mark. Appreciate it. So it's great what Mark was going through talking about as you start to get Hadoop at scale, right? Thousands and many thousands, tens of thousands of nodes. What is it that Yahoo's done to optimize performance, improve utilization, and what they can do? But the lessons of what they've done are the same if you're on 10, 20, 30 nodes. So it's great. A lot of the things they do are transferable, large to small clusters, and they've really spent a lot of work on how do you optimize and get the most performance out of the assets that you have. So now what we're going to do is we're going to switch to the cloud. So I want to bring up Sanjay Radia, who's one of the co-founders of Hortonworks and also chief architect of what we're working on, who's going to talk about the cloud and what do you do with Hadoop to make it run as a first-class citizen in the cloud. So Sanjay, come on up. Welcome.
Hey, hi. Thank you.
Go.
Hi, good morning, everyone. This is a great summit. I was at the first summit. We had 180 people, and this one is close to 4,000. So my name is Sanjay Radia. I'm the chief architect and co-founder of Hortonworks. So one of the themes of this particular summit has been the cloud, and so I'm going to spend the next 20 minutes or so sharing my thoughts on this topic. I'll touch on not only what is possible today, but what areas that we as a community need to evolve the Hadoop ecosystem to make it fit a lot better in the cloud. So let's get started. So why would you want to put Hadoop in the cloud? The cloud really makes your business nimble. You can create a Hadoop cluster in a few minutes. Okay? Each business unit can operate at its own speed, on its own budget. The cloud also saves you time and money. There are no upfront hardware costs. You don't have to hire a Hadoop admin and get him trained, and you pay only for what you use, and you pay for when you use it. The cloud also is very flexible and gives new models of deployment. You can spin up a formal cluster, run your workload, and then shut it down and stop the meter. That's not possible in an on-premise cluster. And further, the cloud offers elasticity. You can add and delete resources to meet your SLA and adjust to your load. So deploying Hadoop in the cloud is actually not a new thing. They've been able to do that for many years. Forrester recently published their big data Hadoop cloud solutions, and they noted there were a number of leading solutions available for a number of leading vendors, including Microsoft, Google, and Amazon Web Services. So while there are a great bunch of choices already available to run Hadoop on the cloud, I think we as a community can really do a lot of work to make Hadoop and the whole ecosystem fit very much better in the cloud and make it really first class. So first and foremost is about storage and the shared data. So the shared data lake on the cloud is the cloud storage. It is not HDFS. And it turns out that memory, local storage, and HDFS are going to play a different role, as I'll explain later on. A big distinction on the cloud is on-demand ephemeral workloads. And this changes things in a really fundamental ways. Shared metadata, governance, security continue to remain to be important. However, they need to be adjusted to work in the cloud, especially in the face of ephemeral clusters. And finally, I'll touch on elastic resource management. And here we really need to shift our thinking from cluster-centric resource management to resource management that is really centric towards workloads and their SLAs. So always on, long-running clusters that are multi-tenant are going to continue to remain important for a whole bunch of mission-critical applications. But being able to enable an ephemeral cluster on the cloud is actually game-changing. The agile nature of the cloud allows you to do that and allows you to create a prescriptive workload. So for example, if you're somebody who is doing data analysis, you really don't want to bother with tuning Hive, tuning Spark, and tuning Hadoop. Really want a pre-tuned cluster that is pre-configured, and so you can focus on your application and on your job. Okay, so whether it is data science, data warehouse, ETL, or some other kind of application, what we really need to be able to provide is pre-configured, pre-tuned compute environments, okay, and being able to manage them in an ephemeral fashion. So the net is we want to deliver user experience that are focused on business agility rather than on infinite configurability and cluster management. So as I mentioned, in the cloud, the data lake is the cloud storage. It is not HDFS. This is very different from a traditional on-premise cluster where each cluster has its own internal HDFS, and that becomes its own internal mini data lake. Okay? Moreover, and really very important here, is that we need to be able to make sure that the data lake is accessible by all applications. Hadoop applications, obviously, but actually even non-Hadoop applications. The native applications that are offered by your cloud vendor or third-party applications from other vendors. Okay? The good news for the cloud is that as far as storage goes, there is geo-distribution is completely built into the cloud. Okay? This makes actually things like DR somewhat simpler. However, the cloud storage has two limitations. It only offers eventual consistency, and its API is not the kind of file system API that Hadoop apps or most normal apps expect. And so this is an area that actually requires a lot of work. And there's a breakout session today around 11:30 from my fellow Horton workers that are going to focus completely just on this topic. So I suggest you go and attend that if you're interested. Also, further, cloud storage is really designed for scale and low cost and geo-distribution. Unfortunately, performance is not a strong point because it's actually segregated from the compute environment. So memory and local storage have to kind of come into play and provide caching to improve the performance. With respect to caching, really you want to focus on both tabular data and non-tabular data. So this is where LLAP comes to rescue. What LLAP does, it actually caches only the columns that are needed and are being actively used in computation. So it's very efficient in the memory usage. Also, LLAP caches the column of data in an intermediate form, okay? Not in the form that was originally on the disk. So it's actually much more optimized for the compute side. The design center in something like LLAP is what is often referred to as anti-caching. And so the model is that you try and put everything in memory, and when it doesn't fit, you spill it to local disk, hopefully to an SSD. Okay. Currently, LLAP only provides a read cache, and we're extending that work to provide a write-through cache. One of the interesting things that LLAP brings to the table is an opportunity to fill a very important security gap that has been in the Hadoop ecosystem from the early days. It provides a convenient place to provide row-level and column-level access control that can be served all kinds of engines, including Hive, which we have been doing in the past, but also Hive, Spark, Flink, or even old-fashioned MapReduce, okay? Now, turning to non-tabular data, this is where HDFS can come to play. It can provide a way to do caching and provide both read and write-through cache. So essentially what HDFS turns into is a place to store intermediate data and also as a caching layer between the applications and the cloud storage. So far, I've shared and talked about shared data and storage and how to improve its performance via caching. Shared data fundamentally requires that we actually have a shared approach to metadata, to security, and governance. So as I talked earlier about having multiple ephemeral clusters, it's important that each of these clusters don't have their own copy of the metadata. Okay? It is important that we actually have a shared metadata for across all the clusters. So this can be done by having a shared database server where you store this, or it can actually be even stored on a native RDS that's provided by the cloud vendor. Okay? The metadata I'm talking about is not just the metadata that is classic Hive metadata about the tabular data. It is metadata about storing and tracking the lineage and the provenance of data. It is metadata related to pipelines and job management. And furthermore, as we ingest data into the system, it's important that we update the metadata. And as we process it, we adjust the metadata and accordingly. Now, governance and securing the data continue to remain important in the cloud, okay? And its metadata also needs to be managed effectively across all the workload. So projects such as Ranger or Atlas, which provide these services on-premise, need to now be adjusted to work in the cloud environment. So the final line to talk about is resource management. Here we'll need to really up-level the resource management. The cloud is really not about the cluster. It is really about workloads and their resource management. So Yahoo needs to manage the resources in the context of the workloads and the SLA. So for example, if it needs to pull in resources, it needs to pull in the right kind of resources. Okay? For example, adding compute may not be the best way to hit an SLA. You may actually have bottlenecks in the data layer and the storage bandwidth. So you may need to actually go and spin up an LLAP node. Okay? Now, the cloud offers another dimension, that of cost and budgets. So there are different costs tied to CPU, storage, et cetera. And therefore, you can actually go and get resources and take cost into account, and also you can take advantage of spot pricing. So to summarize, to be able to better take advantage of the cloud, you really need to understand your workload well and take advantage of elasticity and spot pricing. So in summary, we could lift and shift a Hadoop cluster from on-premise onto the cloud, but I think we're better off evolving the Hadoop ecosystem to fit better in the cloud. We at Hortonworks have been working on this for the last few months, and I'm going to invite my colleague to show you a small demo of a tech preview that we're releasing today. Please join me in welcoming Ram Venkatesh from our engineering team. Hi, Ram.
Thank you, Sanjay.
Thank you very much.
Thank you. Good morning, everyone. So Sanjay gave you a really nice overview of why we want to go into the cloud and what the strategy is, what the roadmap is, what the vision is. I'm going to take you down in the weeds a little bit. Okay, so we're going to take a look at what the actual tech preview is about through the lens of a customer scenario. The scenario I've picked today is from ad management. Today, your customers are coming to you from mobile devices, from tablets, from laptops and desktops, right? So you might have someone browse an ad on one device, then they might browse a product catalog on a tablet, and they eventually end up making a buying decision on a laptop. So the idea is, how do you track these customer experiences across all of these devices to make sure that you're spending your dollars on the right channel, okay? To do this, I have 3 data sets. I have a sales history data set. I have a campaign data set that has my marketing campaigns and promotions that I run. And lastly, I have a clickstream data set, okay? On top of this data set, I want to run 3 workloads. The first workload is an ETL workload, essentially to do some sessionization, to do some user profile matching, and to enrich the data in some way so that we could create a curated data set. And once we have a curated data set, then these other downstream workloads can take advantage of it. So one of the workloads that I have in mind is a data science workload. You might have a data scientist who wants to interactively browse the data, look for predictive patterns, and do some machine learning on the data, potentially. Another use case that I have in mind is, once I have a curated data set, then I want to be able to hand it over to my business analysts for them to do some reporting off of the data, okay? Enough talk. Let's go over and look at the bits. I can see my computer's gone to sleep, so this could be interesting. All right, here you go.
So the first thing we're going to do is take a look at my S3 bucket. So it's called Hortonworks demo data. And inside of that, I have this cross-device attribution data set. It's called CDA small because it has petabytes and petabytes of data to run live on screen today. No, I'm just kidding. This is a small synthetic data set that we use for tutorials and labs and such. Okay? So within it, I have, as I mentioned, the campaigns data set. I have a clickstream data set, and I have the sales and user data sets. So the first step I'm going to do is to log into Hortonworks Cloud. So Hortonworks Cloud is this is part of this tech preview. This is our command and control center to create, launch, and administer ephemeral clusters. Okay, so let me log in. Okay. As I told you, I had 3 workloads in mind, so I'm really happy to see there are 3 clusters up here for me to look at. Right? So the first one, there's this ETL cluster that's going to run the ETL jobs for me. The second one is this data science cluster that will be used by my lab data scientists. And the third is this BI/analytics cluster. Okay? So in this ETL cluster, we're going to be running some Hive scripts periodically to perform the ETL operations. So to show you that, I'm going to drop down into the Hive view. I should point out that in these ephemeral clusters, all of the command line utilities that you're used to, like the Hive CLI and Beeline and so on, they're available. But for today's demo, I'm just going to go through the UI. I know it was a good party last night, so I'm not going to make you read all of the source code on the screen. But essentially, this is the ETL batch job that I'm running. And I want to point out 3 things to you. The first one is, as Sanjay mentioned, our model for these ephemeral clusters is that the data is persistent outside of these clusters. So here, all the ETL is happening against tables that are already defined against the data in S3. Okay? But we do anticipate that the intermediate steps of your computation, let's say you have an ETL job that has 5 steps in it, those intermediate steps are actually going to stay within the ephemeral cluster, within HDFS. And once you're finally done, then you can transparently move the data back into S3. So for example, this IP profile enrichment script is going to eventually land the data back into that S3 bucket. Okay? So there's obviously a lot below the waterline here in terms of S3 access. And as Sanjay mentioned, folks in the community, we've been working on this, both on the code as well as validation and testing and certification across a variety of projects. So Apache Hadoop, Spark, Hive, Tez, all of these projects, there's been significant work done to enable good, consistent S3 connectivity that you get to take advantage of. The second thing that I want to show is, from a metadata standpoint, as Sanjay mentioned, for these ephemeral clusters, the metadata server is also externalized. So here we have this Hive metastore that's being backed by a Postgres database instance that's hosted inside of Amazon RDS. So when you spin up an ephemeral cluster, you can point it to both the data and the metadata that it's supposed to use. Okay? The last thing I want to show here in this ETL job is actually the one that I'm most fond of. So if you can look at this URL, what's not there in it? Right? I'll give you a hint. It has no credentials. It has no secrets. Right? So the question is, how do we make sure that we've secured access so that only this ETL job can actually write to that S3 bucket? The way we do that is by actually tightly integrating with the underlying object store's security mechanisms. So in this case, Amazon S3 has this concept of a bucket policy, and it has integration with the Amazon AWS IAM system, which we can transparently take advantage of. So if I walk over to my S3 bucket, and let me bring up the properties for that bucket. Okay. So you can see that we make 2 statements about read and write access. So up here, we declare that the folks in the data warehouse reader role are the ones who are allowed actually to read access to this bucket. And amazingly, there's a data warehouse writer role, and only jobs configured with that role in mind are allowed access to that bucket. And when we spin up these clusters, it's possible to associate an instance profile with that cluster that says, and here's the role that's been given to this particular cluster by my cluster administrator. So that makes it completely transparent for you no more secrets. So you're not managing secrets and credentials inside of your clusters. It's already set up and ready to go by the time you launch the cluster. Okay. So that's what I wanted to show you on the ETL aspect. Switching over to the data science aspect, you can see that the ETL cluster had a set of services on it, mainly having to do with Hive, Tez, and Spark, because we think these are the most common things you're going to be accessing in an ETL context. Whereas in the data science environment, one of the things I'm showing here is the Apache Zeppelin service. So this is new in HTTP 2.5, and this provides you essentially an interactive experience for you to be able to go in and browse your data, to explore your data, to write little snippets of machine learning code. You can do this in Scala, you can do this in Python, R, and another variety of environments. So this is kind of what it looks like. So I have a Zeppelin notebook here where we are looking at the campaign attributes for my marketing campaign to see how well we're able to predict user behavior and which device the user is actually going to land on. I'm not going to go through all of Zeppelin here, but just want to give a shout out is that in the afternoon, there is a detailed session on Zeppelin. I encourage folks who are interested in this topic to take a look there. So, but this Zeppelin cluster, this Zeppelin service is running in this data science cluster that has been pre-configured with that data warehouse reader role. Okay. The third cluster that I want to touch upon just a little bit is the BI analytics cluster. So here, in addition to the other services that are described around Spark and Zeppelin, one additional service here that's really important is the Hive LLAP service. So LLAP is the low latency analytics processing engine that's part of Hive 2.0. And this cluster template or this cluster definition has that baked into it. Okay? It also comes with standard JDBC endpoints and services, so you could connect up mainstream BI tools to it. That's one way that people could access the analytics services. For this demo, I'm going to cheat a little bit. I'm going to use Zeppelin as a dashboarding engine for us to take a look at the data inside this cluster. So I'm showing you Zeppelin in two modes. One is a data scientist use case, and the other is a more conventional BI use case. So let's take a look at what that looks like. So coming back to the scenario, so what I have up here is I have a dashboard from the machine learning that already happened on top of the data set that's sitting in S3 that was enriched by ETL. So the first pane up there kind of shows you, what your CFO's concern is, right? It says, we're spending all this money on ads on the phone, but you can see that most of our sales are really just on the desktop. So for the most part, there's a small amount of mobile traffic, but it's mostly about the desktop. However, here's your comeback, right? You can see, if you drill a little bit deeper into the individual campaigns, just the Manhattan shows you that all of the high runners, the campaigns that did really well, have this component in the middle, which is converted mobile sales. So if you break down sales by pure desktop sales, converted, and this is interactive, so you can kind of segment things out that way. But you can see that there is this converted mobile sales component that's responsible for a significant lift in the sales activity that you're seeing. And if you were to look at the data a little bit differently, you can see that for campaigns that had no mobile element to it, understandably, 95% or more of the sales are desktop only. However, this is the interesting one. If you do run a mobile campaign, at least for this data set, we can see that about a third of the sales had some component from the mobile interactions. So for this particular use case, for this particular data set, we'd conclude that it's actually a good idea to spend for ads on the mobile device, even though you may not be seeing a lot of business transactions from it. And just for grins, we said, OK, let's look at transactions by time of day. It still looks to be the case that noon and the hour before rush hour are the most popular times for people to shop online. So shopping online at work is still definitely a thing. So coming back here, I just want to wind up with a few, I just want to drill a little bit deeper into a couple topics here. So one is, how do you set up an experience like this? How do you create these ephemeral clusters, right? There's this big green button that's been calling out to me to click on it since I started. You can see that there's this very prescriptive, small set of things that you have to fill out. Essentially, you have to put in a name for your cluster. You have to pick a cluster type, right? and then you had to put in your passwords, and off you go. So it's a very, very prescriptive, quick to onboard kind of experience. And for us in the Hadoop land, this is a novelty for us, right? We never saw a config parameter we didn't like, but this is where users want us to really go to, right? The other thing I want to point out here is, among these cluster types, there are the familiar ones like EDW, ETL with Hive 1.2.1 and Spark 1.6, but there are also some new ones in the camp. There's the Apache Spark 2.0 tech preview based on the tech preview that's in the community. There is also the Hive 2 LLAP Apache Zeppelin configuration that I touched upon briefly. So these are examples of why another angle to why we're excited about the cloud, is that we think that this is a fantastic way for us to get you early access to bits that we are working on, not just in a sandbox environment, but something that you can run against your own data at scale. You can give us feedback earlier in the cycle. We think for the whole community and the ecosystem, this is really critical for us to be able to innovate faster. And this is one of the preferred ways that we hope you will get to consume this technology. So we are pretty excited to showcase some of these new technologies in the box, and we're waiting to hear your feedback on how this works for you. The other thing I want to mention here is, from an elasticity standpoint, each of these clusters can be right-sized for your user workloads, right? If you have a large number of BI folks, but just a couple data scientists, you can right-size these clusters. You can make it self-service, so they can come in and configure these clusters the way they want them to. However, you can also scale them up or down as required. And there are a couple ways to do this. One is the manual option. As an admin, you can go in and scale a cluster up or down based on what it's doing. There's also, under the hood, there is a fairly extensive auto-scaling framework, which looks at the characteristics of the workloads that you're running. So based on the size of your job, based on the number of users you have right now, based on the number of pending jobs that you have outstanding at this point in time, all of those are ways that you can use to actually determine your auto-scaling policies. So this gives you a very convenient, easy way to take advantage of some of the enormous advantages of running in the cloud. All right. So basically, coming back, this is kind of what we showed you today was a way for you to launch ephemeral, elastic clusters that are enterprise ready. So I think just as of this session, we announced a blog showcasing this tech preview. And here, I'm just browsing the documentation for it. So right from within here, there's a way for you to launch the template and actually go ahead and create your first cluster. With that, let me hand this over back to Sanjay.
Hey, thanks, Ram.
Sure, thank you.
Great. So the last 20 minutes, we kind of focused on optimizing Hadoop workloads in the cloud. Many are ephemeral, and some of them will be always on. The use cases span machine learning, historical analysis, but also streaming analysis use cases. So at Hortonworks, we're really focused on enabling a connected data architecture that spans seamlessly both the cloud and on-premise. In this era of Internet of Things, it's very important that we manage the entire life cycle of data at rest and also data at motion. So as an example, let's look at, on the screen I've shown an architecture of a hybrid infrastructure. And so let's say, let's look at it in the context of a car manufacturer. In the upper left-hand corner, what you have is data coming from a connected car into the cloud, and you may perform analytics, streaming analytics, close to the edge. That data is going to be clearly routed to other parts of the cloud where you're going to do other use cases such as machine learning. On the bottom right-hand corner, I have data coming from a manufacturing plant, into the data center. And what you really want to be able to do is to route the cloud data into into your data center so you can actually have really a complete historical view of the car. If you combine these two pieces of information, the manufacturing line data and the operational data coming from the car, you may be able to unlock some root cause manufacturing defects that are manifesting themselves in cars on the road. In this world of next-generation set of applications, I'm really excited about evolving the Hadoop ecosystem to work for these new kinds of applications and also to work for these kind of hybrid infrastructures. Today, Hortonworks, as you've shown, we are releasing this tech preview that Ram demoed. He showed you the page. I really encourage you to try this out. and you can go off and spin up a cluster, in few minutes. Also, there are a number of interesting breakout sessions today I'd like you call attention to. There is a session at about 11:30 on Hadoop and cloud storage, and that goes into some of the things I talked about, how to improve the use of cloud storage in production. There's a session on LLAP in the middle of the afternoon, and also a session on Zeppelin and Levy at the end of the day. Thank you very much. I hope you enjoy the rest of the conference.
Thank you, Sanjay. Okay. Thanks for taking them through that. I definitely would encourage everyone to go check out the tech preview running on Amazon and what you can go see there and how that's working. But great opportunity to see how, as you move to the cloud, you move right to a different environment across shared metadata, shared storage, and the other pieces. And I want to thank Ram for the demo that he walked through. So we've got another demo coming up now, what I'll call our data hacks and demos. What I'd like to do is bring up Joe Witt. So Joe runs engineering for our HDF product line, but also, probably more importantly, Joe is the founder and creator of Apache NiFi. So welcome, Joe. Thank you. And by the way, Joe is technically a hoodie, camouflage as a suit today.
Thanks, sir. I don't need it. We're good. Thank you all. It turns out there is a lot more of you than I anticipated. So what Herb actually asked me to do a couple of weeks ago, and this is because he had heard about my many very interesting talents, is he said, Joe, what I really need you to do is get the crowd pumped up, right? So he said, I want you to go out there and dance for the crowd, play the violin, and sing Highway to Hell. But despite the fact that Herb's my boss, I said, no, I am not going to do that. I know what they want. What they want to see is a series of very cool tech demos, weaving things together. But then Herb said, there's a catch. You may not use PowerPoint, at which point I became useless. So what I've done today is I've invited a few people here to help me tell that story. First up, we have Jeremy Dyer from Hortonworks. Thanks, Jeremy. We have also joining us all the way from Germany, Kay Lurch. Kay is somebody who we found a few months ago. He's been contributing to the Apache NiFi community, making some really cool demos showing how you can use things like NiFi and Amazon Web Services together to do some interesting collection and visualization of data. And we also have Simon Ball from the UK Hortonworks team. I first want to say thank you very much to all of you for coming out and helping in all the work you've done putting these things together. So what we're going to do is we're going to take a series of demos that cover things that actually tie into what's going on these days. What we want to do is walk through collection of data, and what are some of the mechanisms that you can to do that, dealing with sensors, sourcing data, and then doing more interesting processing of that information. How can we make that data more valuable, tie it in with other information, and then ultimately, what's that sort of analysis that we can do? To make this more kind of realistic and interesting, we want to tell it sort of in a narrative that goes along with what you might expect from a retailer, right? As you walk into a store, what sort of engagement would you expect to be happening? That retailer, as you come in, they want to learn about who you are. They want to understand maybe your identity. They want to learn what kind of a shopper you are. What are the things that you might be interested in? What other data can they combine that with so that they can then engage with you, maybe make you an offer or something interesting like that. I would ask each of you to get your cell phones ready so that you can, later on in the demo, actually participate with us as we collect more data. So we're going to run a vote that we'll talk about. We'll either have you send a tweet or an SMS message. Either one's fine. For those of you who want to furiously start scripting so that you can win the contest, get yourselves ready, have fun. But we'll run through those now. So first up, we have Jeremy Dyer, who's going to talk through what's this sort of processing, or what sort of collection can we do. A few of you, well, many of you, over the last several days in the conference, maybe knowingly or unknowingly, have participated. We'd like to thank you very much in our gathering of data, much like as would happen as you entered a store. So Jeremy, why don't you take it from there?
Sure. Thanks, Joe. So to Joe's point, in retail locations, there's actually a lot of perishable insights that stores and companies are actually losing, right? Most stores and most digital businesses already take advantage of web trends and their web presence to gather things like logs and mine data about their users. However, what most people are losing, and just simply because it's actually can be quite difficult, is capturing the physical interactions that people are having within their stores, right? They're doing a lot of things. They're on their phones, They're interacting with your products on the shelves, and their behaviors as they do this is actually quite interesting. There's things you can learn, such as, are they interested in my products? Am I stocking the right products in my store? These are questions that are very valuable both to the consumers, as it makes them, they're more happy because they have products in the store they're interested, and to you in terms of actually financial returns. And even such things as monitoring their Wi-Fi traffic to notice if they're maybe price shopping on Amazon while in your store as well, right? I think that happens a lot. So with that kind of spirit in mind, what we wanted to do with my portion of the demo was actually illustrate how it's pretty easy with Apache NiFi, using it as sort of the plumbing to capture these sort of data sets that are already present in stores, right? There's Wi-Fi, almost every store has, in-store CCTV security cameras. A lot of stores have iBeacons, so it really doesn't even require any kind of extra investment on the store's part. They're just kind of already set up to do that, they're just not capturing it. So to Joe's point, what we did over the past 3 days in the conference was kind of take you guys and have you participate with us, right? I appreciate that, by the way. So we had a Mac Thunderbolt display that was set up, and you can see this in the middle piece. This is a NiFi flow that was actually capturing data live for the past 3 days off a Thunderbolt display camera. We also walked around with a cell phone and kind of a little wireless Bluetooth speaker I had on my backpack, and we were taking pictures of people and providing some feedback, right? What we really wanted to illustrate is that we're processing data on the edge, right? So NiFi is about that edge-based processing, but it's not limited there. We can take that data, do the processing, send it up to another NiFi cluster in a more server environment, do some more detailed processing there, maybe interact with databases that are not really feasible to push down to the edge, and get some more kind of pertinent information. So what we decided to do is take these pictures of you guys. Everyone will notice you have a barcode on the bottom of your badge. We would actually extract that barcode ID and then look up some pertinent information about you through that, and then kind of match that to your face, and then kind of push that up to the cloud, which is another tier where we could do some more kind of, a little more rich analytics on that.
So Jeremy, there to that point, right? If you think about how these kinds of things happen, you have these edge systems, these sensors, capturing raw data. They don't have a lot of compute power. They don't have a lot of storage power. They're really just focused on sensing information. In a store context, you can think about that information, just like Jeremy described, going to another system, kind of a more back office system. But ultimately, that data's got to get backed up to the cloud, where you as an organization have the broadest view, the largest ability to acquire and combine information, and that's what Jeremy's describing there now.
Yeah, exactly, Joe. So the idea is we want to gather it there, come back, but then we also want to interact with the user in the store, maybe send them a coupon on their phone, or maybe give them some kind of audio feedback. So in fact, that's what I'm going to demonstrate here. So I dare not use a live image, so I'm going to use a pre-baked image of myself from yesterday that was captured, and I'm going to show you that here. Not very flattering.
Beautiful.
But we're going to take this picture, and we're going to kind of put this in a directory that's being watched for this files, or for these images, and show how that's going to be processed, pull out my barcode, and then kind of interact with me back through my Mac here. So let's do that now. I'm going to drop that. It just so happens to be my download folder. Make sure that's running. So let's talk about how this runs through the system, right? So we have data flowing through here. This is running on my Mac where I drop the file, okay? So it's looking for that file, picks it up, and then sends it to the back-end server instance. The back-end server instance here is actually listening for the data, running it through a detection algorithm. So this detection algorithm is actually not part of NiFi by itself, and I did that because it's easy to illustrate how easy it is to actually develop new processors that can be a part of NiFi. So I created that here, and that is ran then through the barcode system, which, when the barcode is detected, looks up in MySQL the information about my first name, my last name, what company I work for, and stuff like that.
Yeah, so Jeremy, hang on there for a second. So that's a key point, right? When you look at these systems, out of the box, they're going to come with a lot of the plumbing and capabilities you need, but there's always going to be scenarios where there's some specialized processing, maybe some proprietary functions that you want to perform. The key then that you want to have from all these systems to be able to easily extend them, and that's what Jeremy's just described.
Yeah, so sorry, the volume was actually muted, so I need to try that again. That's interesting. Okay, so here we go.
Hey, Jeremy from Hortonworks. How's your travel from Atlanta?
So what it did there, actually looked at, pulled my barcode, and like I said, looked up the information about me, generated some text, and then ran through a text-to-speech processing engine on my Mac here to do that. So we've kind of completed the round trip there.
Just so that we can make it start to feel a little creepy.
Exactly. And a tier up from there is actually moving on to Simon, so I'm actually sending him this data too, and we can do even more interesting things, and that's where Simon comes into play.
Great, thanks, Jeremy. So what you see from that is a pretty simple way to start collecting that information. Now, Jeremy's just shown a pretty simple scenario of taking kind of media images, maybe starting to tease apart different pieces of that data so we can do things like identify who we might be working with. And now we want to get that information up to the cloud where we have more powerful resources to operate on that data and process it. Simon, can you describe to us what sort of things you can do from there?
Yeah, sure. So let's start the second demo.
Demo 2, please.
And what we have here is a cloud-based cluster. This is just an ordinary HDP cluster, along with HDF on the side, to be able to receive the data that Jeremy's sending us. The important thing really about what we're doing with Jeremy's side of things is that we can do a certain amount of edge processing with the facial detection. So at a small store location with limited hardware, limited compute power and storage, you can get away with just about pulling out a face from an image. What NiFi gives us then is the ability to prioritize those images and start to process the ones which are rough cut more interesting than the others. What we're doing with those images that Jeremy's sending in is then sending them across this site-to-site link to NiFi along with that metadata that he's captured from the badges. That then goes into a Spark-based algorithm, and we are using, of course, Zeppelin to drive our Spark. What we have here is quite an interesting use of Spark. We're integrating Spark with an additional library which has very good Python bindings and is specialized towards computer vision machine learning. So the interesting thing here is that we're able to use Spark not just for its built-in machine learning capabilities, but also for its wider ability to parallelize across very large data sets. So here we can do slightly more sophisticated analysis of the images that we're getting up from Jeremy. We can start to combine that data with other data sets, so say our entire customer database, which isn't practical to store on a Raspberry Pi in a store. We can also do things like facial alignment with this and benefit from the capabilities of Spark's built-in support for things like NumPy in particular, as well as its ability to crunch large numbers of matrices to be able to start to align those faces towards something which is more like a facial recognition algorithm. So while out of the store processing, we can get a little image which is just, yeah, that's roughly where a face is. With the more complex algorithm, we can start to do things like identify facial locations, have a bit more computing power around that, then take those facial vectors, pass those into classifiers that we can train across our entire set on Spark, and start to spit out things like the names of people from just their images, from their faces alone. So as soon as you can label those faces, be that with a name from a badge, or be that from some other source of information or looking at your CCTV, you can start to line up those names and faces against other sources of data that you have in your organization.
So Simon, in this case, what you're doing is you're wiring together systems like NiFi to help orchestrate the data flow, systems like Kafka to act as that substrate between all of the analytics and processing that you're doing. And this is running on Azure, is that correct?
Correct, yeah. So this is all running in a combination of NiFi running in Azure to collect the images and process those into an Azure HDP cluster, which then runs the Spark pieces on top of Yarn.
Great. And then Zeppelin as the mechanism by which you're looking through that data more, right?
Yeah.
Okay, can you bring up the instructions on how we can start to get folks to interact?
So, yeah.
Okay, so what you've seen so far is a little bit of that collection phase that we wanted to go through to capture some information about who we're working with. We've then started to combine that information together in the cloud to do some of that additional processing, gather more context, get a little bit smarter about how we might want to engage with the consumer. And so now we have Kay Lurch who's going to help us with capturing more information. So now we've decided we want to reach out to you directly and ask you pointed questions so that we can get even smarter about what sort of offers should we go to you. So for those of you with your phones ready, please do participate. Excellent. So send either hashtag A or hashtag B via SMS message to this number on the screen here. Or send a tweet to @HadoopSummitDemo and then hashtag A or hashtag B. We made the tweet long enough to make it stressful for you. So feel free to send through as many votes as you like. We'll talk about them at the end. And what we'll do to make things more interesting, for those of you who waited to vote, is we will select winners, 2 winners, and we'll give you these very fun light boxes. So in there's a Raspberry Pi, a battery, a K-powered or K-inspired wooden box, and a 32 by 32 LED light array. So go ahead and let the votes come in. That's actually pretty good. We didn't even tell you what you're voting on yet, so that's even more impressive. I'm starting to think my mom wrote a script in the background to just randomly vote. Anyway, so what we thought would be an interesting voting topic, and actually it appears completely irrelevant at this point, but let's tell you anyway. Since we're sort of in this like capturing data about consumers and trying to understand what they're doing, it brings up some interesting questions, right? Some sort of deep thought sort of situations of, is this as a consumer something that excites you, right? Do you think of this as a great opportunity to be able to engage with the store better or have a better consumer experience? If that's the case, vote B. You're excited about this. Or does it make you kind of nervous? Do you think about the compliance implications or the privacy implications? Are you worried about how that data is being handled? And if that's the case, vote more concerned. And I thank you for making that completely irrelevant at this point. All right, Kay, so can you go ahead and describe to us, and by the way, fun fact, the green line there is showing you that we've already rolled over on 1,000. So you guys are more excited. I should have actually told you, this is actually a Trump versus Clinton thing. I'll tell you. Anyway, I got other bad jokes. So, Kay, if you could describe to the crowd what's sort of happening behind the scenes. How is it that we're making this happen?
Yeah, thanks, Joe. Yeah, I want to add some real-time user-generated information. So after Jeremy collected some data throughout the summit, and Simon already did some great analysis on it. So Joe asked you to vote on a specific topic, and you're already busy on this. And there is twofold. One is the SMS, and we received the SMS over Twilio, which is a SMS cloud service, as a webhook. And we ingested data to another NiFi instance running on AWS EC2. And we are also ingesting the tweets by leveraging the Twitter streaming API. So what happens with those messages coming in? We pass your vote, and we hand it over to AWS IoT. And AWS IoT is our gateway to communicate with those light boxes over MQTT. And we are not actually communicating with the light boxes because they are wooden. But there lives a Raspberry Pi inside, and this is wired to a 32 by 32 LED panel, and it's controlled by it. So if one of the Raspberries subscribed to an MQTT topic of AWS IoT is receiving a message, it indicates an incoming SMS as a red flashlight and an incoming tweet as a green flashlight. So, but moreover, the Raspberry Pis are also wired to a sensor. And what we do here is not to give you only the chance to generate a physical event here on stage, but we also provide you some information from the stage. So maybe some of you already got a response SMS. Raise hands. Okay. Woo. So we are limited a bit on outgoing SMS, so it may take a while. But as soon as you get one, you know exactly how warm it is inside those light boxes. So it's a feedback. For those of you who tweeted, there's no really chance for us to get back to you because of the Twitter service limit.
What it means is we would have had to pay.
Yeah, okay. So, yeah, but that's it so far. Try it as often as you want. You might recognize some slight changes of temperature and humidity. And yeah, this is because of the sensor. So we bring this back to AWS IoT, and this is persisted in a thing shadow. And the thing shadow is the virtual representation of the sensor. And this is read out by NiFi, and NiFi gives this information back to Twilio, and this is how you get your SMS.
Hey, Kay, quick question. How much power does it take each time they vote? The reason I ask is because it looks like one of them is gone. Check it out.
Oh.
Yeah.
Okay.
Does anyone have?
When did this happen?
Dead battery, man.
Nice.
Okay. And now
Now
it's
that
the
the
other.
boxes are dead, we will definitely give
They
them
are
away.
close friends, so they do the same, yeah.
Awesome. Well, thank
Okay.
you very much, Kay. So what you can think about there, just kind of a simple way, right? When you send an SMS message, for example, that data is obviously going through the cloud service twilio that we talked about. NiFi is grabbing that information, firing it off to Kafka. There's some initial database loading that's happening in the background, and then information being sent through AWS IoT. And that's causing the light boxes to fire up and then use up all the battery. At that point, throughout that whole time, we were streaming that information back to where Simon could do additional analysis. Maybe just to kind of close out, Simon, you could talk a little bit through what sorts of things we can do with that data now.
So one of the other fun things that we wanted to do was, because we're all about community here at Hortonworks, we wanted to bring in some of this data from the Hortonworks Community Connection and make that a factor in how you've participated. So thank you all for your excellent participation in the voting and for killing the temperature of the light boxes. But we also wanted to thank you all for all your participation on Hortonworks Community Connection over the last year or so. So we're bringing in some reputation data from various people who've contributed to HCC, very skewed reputation data there. And then linking that back to some of the Twitter data. So while this is relatively clean, nice internal data, we find that a lot of the pieces we're getting from the tweets are not. So what we're using with that is using Spark to be able to federate querying across multiple data sources, so to process JSON data raw without having to worry about schema. We're then looking at the data that we've extracted from Twitter, again using NiFi to make sure that we didn't exceed those rather expensive rate limits we hit earlier. What we're then able to do is bring all that data together, start to visualize that, start to see the distributions of duplicates of names, and realize that it turns out there are an awful lot of Brad Andersons on Twitter. So we need to find out who is our Brad Anderson. So what we're doing then is using all that data that we've collected, pushing that into a Spark ML model to be able to cluster that, to identify communities within that data based on NLP. So we've managed to find the Hadoop people and the not Hadoop people. So if we look at the results from that, then we, a little bit of a test. I'm pleased to say that I do fall into the Hadoop-friendly camp of this cluster.
Congratulations.
So it seems to be working. Once we have that data set, we then push that through a storm topology, which is processing those, someone really has scripted that up very, very fast, which is processing the stream of incoming votes in real time, augmenting it with that information, and then pushing that back into the back end that we will use to decide who actually gets the light boxes.
We got to figure out who managed to kill the boxes.
Yeah.
That'll be fun. Okay, so thank you, Simon. We'll sort of wrap it up there. Just kind of wanted to walk you through a fairly, faces of the conference, get mine off of there. Just walk you through a fairly simple scenario of how can we start collecting different streams of data, tying them together and processing them, and doing some analysis. I want to say thank you all very much for helping put this together and putting the effort into piece these together. And thank you all for participating in the voting. Certainly made it fun. We did not plan on the boxes dying, so very impressive. Good job. But we'll leave it there. Thank you.
Thanks, Joe, Jeremy, Simon, and Kay. And now we'll hear from Carrie James, Director of Big Data Solutions at EMC.
Thanks, everybody. As they said, I'm Carrie James. I'm with EMC. I'm Director of Big Data Solutions for us. We're going to change gears. You guys have been hit with some technical things this morning. We're going to focus a little bit more on the data analytics journey and some of the things that we, EMC, have encountered as a consumer of big data solutions and also as a vendor in this space. And walk through those pieces to understand how does preparing for this journey actually help us set up for success. This slide should not shock anybody at this conference, right? Data defines our world. There's huge amounts of data, smart connected devices. Almost every one of us in this room has one in our pocket of the successors of one of the predecessors of this device that are generating new and huge amounts of data. The actual challenge here is companies are trying to solve is how to use that data to actually provide benefits to consumers, how to increase the speed of their products and deliveries, how to increase the efficiency of their operations, and even how to change how they engage and interact with their customers. We at EMC actually have a recent history from us. This point is that for a long time, our devices have actually been feeding data back. We call it phone home. But that phone home data is used by EMC mainly from a product management perspective, and then if there's an issue at a customer site. But in recent history, we've actually begun to manage that data and now mining that data and being able to provide it back to the customers in what we call our customer service portal in near real time. So now customers can actually come into their portal and see how their system's actually operating from the phone home data. Let's make no mistake, right? This is a journey. It's not a quick trip to the corner market. So there is some proper planning and preparation that has to go in place to give us our best chance for success. However, as like the Hortonworks guy said, right, we want community. We firmly believe that big data is a team sport. And we think this is a journey that's best taken together with organizations. EMC and our partners have gone through a lot of these pieces as we've grown up. So we've been, again, living this journey for the last 5 to 6 years ourselves as an enterprise. And a lot of what we see in this next conversations is what we've actually learned from our own journey. The first thing we have to understand is what is our destination? And by destination, we mean, in this context, is what is the business objective that we're trying to achieve? Am I trying to create new revenue? Am I trying to improve my products and services? Or am I trying to change or enhance my customers' experience and their interaction with me as a company? It's understanding these business outcomes and being able to focus on which ones are important to us that will actually set up our organizations to be able to make the journey together, right? So it's not just technology, not just business. We have to make the journey together as an organization. Once we understand where we're going, we have to understand how are we going to get there, right? And there's going to be a lot of things that define technology decisions that guide our path to our final destination. Behind me, you'll see on the screen some of those sample ones, but very basic to what we do in the big data space. How much data are we going to collect? Are we going to collect streaming data, batch data, structured data, unstructured data? Is the data that I'm going to ask an answer of, it may need different tools and different storage mechanisms to be able to support that. And what we've learned, in the example of our phone home data, is that data will have different business value to our organizations at different times along our path. However, data and insights are awesome, but just as important is how are we going to use that data and those insights to actually create applications that allow us to transform those insights into action. Because it's only through the creation of actions that we actually can generate value for our business organizations. And as they say, right, every journey begins with a single step. But what is that first step? Early in our history, and in most conversations we have with organizations, when we're talking to organizations about they're embarking on an analytics or a big data journey, we get I'm going to build X technology. Our first response to them is, great, but what are you going to do with it? So technology is where most companies think the first step is. I know it's kind of funny, maybe hearing this at a technology conference from a technology vendor, but we don't believe that to be true. From our own experience, through our customers' experience and our partners' experience, again, we must focus on the business outcomes. What we found is that most companies have a business strategy. We all know it, right? Those business strategies and their business units drive business initiatives. It's those business initiatives that will then drive individual projects. And that project is about a specific business question we're trying to answer. And it's that specific project and that specific business question that's going to drive the data and technologies that we need. So if we focus first on data and technology, we actually don't know where we're heading. However, we also are smart, right? We're at a technology conference. There are going to be technology choices that shape how we get there. And we'll talk the next couple of slides about some of the things that we, EMC, encountered in those technology decisions and what things we actually looked at. So we all know that past data is a powerful predictor of future patterns. However, in our journey at EMC, we found early that most of our data was locked up in silos: marketing, finance, product, operations. which made it very difficult for us to actually predict those future patterns, get cross-dependency and cross-relationship information. And that made it difficult for us to get to the insights that our business was asking us. And we coined the phrase along this way was that data silos were the anti-data science. So we started, like most companies, said, hey, we'll move most of this data to a single place. We can start accessing this data, breaking down the silos. As you guys all know, are probably aware, that creates its own set of challenges. We had to look and say, we can't just store this data in a central place. We have to put tools and management around this ecosystem that allow us to manage ingestion of data, that make it, we can apply enterprise security to this data, so control access to and utilization of data. We also, once we did that, we started getting more and more and more data into our ecosystem, and it made it very difficult for our data scientists to actually find the data. So we also had to put in tools to make index and catalog to make it easy to discover what we were looking for. Last but not least, we also had to add data protection to this as we started moving this into our business operations. Without data protection, we couldn't actually truly convey and manage that value for our business. As we've talked about, right, from the other part of this is there's points we had to speed up our journey. We had to change our journey from what we were doing. The phone home data is a great example. We were normally collecting that on a daily, weekly basis, depending upon how many appliances were at a customer and what was happening in those appliances. That doesn't work when I want to be able to put this data in a near real-time portal in front of a customer. So we actually had to create different mechanisms to manage the ingestion and the management of that data to be able to provide it back to our portals. However, we could not break the processes and flows that were being used by our product, our operation systems for their traditional batch processing and long-term analytics of that information. This is probably my favorite slide in the whole deck, right? Anybody been involved with analytics over the last 5, 6, 7 years realizes that we've had to do some weird things to make things work, right? We had to find out, hence a car on a lake driving as a boat. We had to put things together, and in our early days, we found that our data scientists and our IT resources were spending the majority of their time just trying to wrangle the environments, just trying to build out the cluster so we could actually get data and drive analysis. We were able to look at this and say, how do we kind of flip this? You heard it a little bit earlier about talking about putting Hadoop on the cloud. We looked slightly the same, but slightly different. We started creating private clouds where we could actually have IT build virtual workspaces for our data scientists. That allowed our data scientists to then start focusing on business outcomes while IT focused on minimizing the details of IT to our users. And those were good, right? So we solved a lot of things along the path. We've now reached a point in our journey about 5.5 years later that we can actually look back and understand that's great. We've simplified steps, we've made life better, but we did that, we simplified steps. So we looked back and said, how can we take that and expand it to helping to simplify the journey? So what we were able to do is take that concept we did of creating virtual spaces from IT and actually develop a self-service ecosystem. So our data scientists could actually create self-service workspaces, deploy the tools they needed to answer the question, and to access the data they needed based on governance policies to answer those questions. That made it easy for our data scientists to now get tools, get data, and drive insights. But again, we talked about, right, that's half the journey, that last box earlier. We actually have to be able to make it easy for our data scientists to be able to share those insights with our application development team, so it allows us now to leapfrog the technical complexities, and it allows our data scientists to focus on generating insights and our application developers to transform those insights into action so we can actually generate value for our company. As we've said, right, this is a journey. It's very seldom that two companies are going to pick the same destination, and even if they do, even less likely they're going to pick the exact same path to get there. That's why EMC has taken the approach of creating a portfolio to address the big data space. No, there is no one answer for everything. But by breaking things down into data lakes, data lake extensions where we can actually handle different types of data, systems and solutions, coupled with services, It allows us to help you simplify each step, regardless of where you are in your journey, and allow you then to become truly focused on what's important is the business outcomes. As we said, we fully believe, and to our core, that big data is a team sport. That's why we formed a strategic partnership with Hortonworks years ago. And part of that partnership is designed to help us build solutions that help to continue to break down the technical obstacles for our customers. We have support of this partnership all the way to our CEO and the president of Hortonworks, and that's awesome. But more importantly, we also have support all the way down to joint engineering, certification, and validation. So that way we can ensure that the solutions we deliver to our customers jointly actually do what we expect them to do, help the customer move past the technical obstacles and focus on business outcomes. As we like to say, we focus on the integration so our customers can focus on the innovation. The one thing that we found through our own journey and through the many journeys and experiences we've had with our customers is that to be successful in the deployment and utilization of analytics, it's not simply about finding the right tool. You also have to work on changing the mindsets and the cultures of the organizations to be able to take advantage of and be able to react on those insights. As we've said, let's take this journey together. We truly believe that we're on this journey together, not only as a vendor, but also as a consumer of big data spaces. We've partnered with people like Hortonworks to help create solutions that can help you safely arrive at your destination on your journeys. If you'd like more information about the EMC portfolio and how we support big data, or better yet, if you'd actually like to see a demo of our self-service solution, please come see us at booth 703. Hope you guys enjoy the rest of the summit. Safe travels home. Thank you for your time.
Thank you, Carrie. Please visit EMC in the Hadoop Summit Community Showcase. Please help me welcome Drew Lehman, Director of Advanced Technology Solutions at Comcast.
Hi, everyone. I'm thrilled to be here today and be part of this great technology conference. Herb and team at Hortonworks asked me if I'd be willing to share with you some of our business transformation as we've adopted big data at Comcast. First off, at Comcast, we have a passion for great products. Up on the screen here, I have some shots of our X1 video service, which is part of our Xfinity product suite. This is a video service that we developed that has won an Emmy Award for excellent customer experience and for visual design. And we're really proud of this product. This is our flagship video product. It includes mobile applications that allow you to take your favorite content with you by downloading it to your device or by streaming it wherever you are. We've developed a voice-enabled remote that's allowing people to interact with their entertainment in ways that they haven't before, and has opened up accessibility to that platform to people who previously couldn't use it themselves. This is something we're really proud of, and we, again, have a passion for great products. We have a mission, though, at Comcast beyond products. We want to make customer experience our best product. And hopefully that's something that resonates with all of you. We not only have that video service, but we're considered a multiple service operator. We also have services in high-speed internet, IP telephony, home security, and automation. And we want to surprise and delight our customers with their experience. We want them to be smiling and enjoying their service like all the people in these pictures constantly. This chart represents our hierarchy of opportunity and how we do that, right? So first thing we want to do is have 100% reliable products and services. And we're building and engineering our products as best we can to do that. And it's not always going to be the case. So when we do have an issue, we want our products to be able to self-heal, right? Automatically correct any issue that there is. And then next is the capability for our customers to self-serve, right? We need them to be able to get the information that they need themselves, and then if they can't get that, then we need to make sure our agents are equipped with what they need in order to be able to solve their problem. And then our technicians who are out in the field as well need to be equipped with information and data. Data is at the heart of all of this, right? So talking to you about our Hadoop transformation, right, within the company. And first, I have to tell you that everything that we do with data is done in compliance with the security and governance requirements for our industry. We take that very seriously. And as we've adopted Hadoop, we as a company have gotten new capabilities, right? And this open source nature of this environment is driving innovation for us, right? We not only have the ability to benefit from this technology, but to contribute, to modify, to enhance ourselves. And we're ultimately getting business value from it. So in this chart, at the bottom, we're showing that we've developed self-service analytics capabilities, and I gave a talk yesterday where I detailed that. So if the video for that's online, go check it out. We also have the capability to do machine learning at scale and also simulation. So we have very complex networks and systems, and we have used Hadoop to create the ability to simulate how those things like content delivery networks operate and then start playing what-if games so that we can give guidance for how the engineer should design the topologies of such systems. And then what I really want to focus on, though, as we talk about customer experience, are these last three items. We've developed a customer event hub. We've moved into real-time collection and processing of data, as well as active decisioning. So what does that mean? For us, you often hear, we call it the customer event hub. Some people call it customer 360. But as a large organization, we have many silos of data, as you can imagine. And as we've been bringing those into Hadoop, we've not only brought them into HDFS, but we've also ingested them into Apache HBase, which is part of the ecosystem, right? And having this information in one place, instead of in these disparate silos, has given us the ability to have a holistic picture of what the customer's experience is, so that people within our company are no longer digging through these different silos trying to understand a customer's experience when they're trying to solve an issue. So basically, this has given us the capability with sub-second response time to get that holistic picture of a customer, which has opened up all sorts of opportunities for us to improve customer service, to the point that this service within our company has gone pretty much viral and is being used for all types of initiatives. So once we have this capability, then the focus comes into real-time collection. So having a holistic picture is only so interesting unless you have information about what just happened. What was the error that just happened? If a technician in the field doesn't know that, then it's not that helpful, right? And so we've been working on real-time collection processing, right? And so our source systems are feeding in. We're using NiFi, just like Joe Witt and team demonstrated for collection enrichment processing. We are also using Kafka as that robust message bus. And as messages flow through, the other thing that we're focusing on in governance is we're wrapping all of these messages in Avro schemas and using a schema repository in order to version schemas. So with a large footprint like we have, it's not reasonable to think that we'll update all of the producers of real-time data at the same time, right? And so we need to be able to manage these versions of schemas across all of them. And then we're using Spark Streaming presently to do some things around managed state and long time horizons, which brings me to active decisioning, which I mentioned before. So active decisioning we think about as this idea that real-time data really is the key to fixing, to improving customer experience and making it our best product. And that's that we need to know something happened in order to fix it. And we want to do it quickly, right? So we need that real-time data. So once we have it, we detect the things that are of interest, we make a decision about how to fix it, right? And we do something like call an enterprise service, send a communication to a customer. Ideally, we want these things to be automated, right? But here's where it gets interesting. Not every action that you do might be have a good outcome for every customer, right? Not everything is clear cut. And so machine learning comes into play, right? So we're working on scoring all of these actions in order to make sure that we're only performing actions that we think will have a positive outcome. And at our scale, with tens of millions of customers, hundreds of millions of devices on our network, the performance of these models is very important. So we've been focusing on that as well, making sure that our models are performant. At this point, I'd like to share with you two use cases that are very different from each other. Try to pick ones that would be interesting in different ways. And the first is coming back to that self-healing use case. So if on our plant, there is an RF channel that a customer's device is talking on, so for example, a set-top box, if noise enters into that RF channel, that can cause customer experience issues. A customer could experience latency in changing the channel on their television as a result of that RF noise. And so what we'd like to do, what we are doing, is detecting through real-time, that scenario through real-time streams, detecting that latency and channel changes, and then trying to correct it automatically via switching the user's device to a different RF channel that ideally does not have noise on it. And the use case sounds relatively straightforward, but when you think about it at our scale, it is quite a massive problem to solve. Next is a use case around customer engagement, right? So a lot of times, one of the things that can be a disruptive opportunity is when a customer moves from one location to another. Now, how we deal with some of the events that we might observe on our network in this scenario would be different than in a normal day-to-day scenario. If we see a set-top box power down, that might be expected for a customer who's moving versus one who is not, right? And we want to be engaged with this customer all along the way. There's many different systems involved in a customer's change of address because they're going to a different physical location on our network. And so systems like billing systems, provisioning systems, and whatnot are all involved in this, and scheduling of technicians, self-install kits, and whatnot. And so we've created a way to have a consistent communication with the user as they move through this journey of moving from one address to another, and providing them a great experience where we're communicating with them and setting their expectations and giving them just a great experience. We have many more use cases as well. And I hope that all of you, I hope that this message of making customer experience your best product resonates with you as well, and that you'll join me with leveraging this entire wonderful ecosystem of tools in this mission for your businesses as well. Thank you.
Thanks, Drew. We appreciate you sharing some of the exciting work taking place at Comcast. Ladies and gentlemen, please join me in welcoming to the stage Robin Purohit, Group President of the Enterprise Solutions Organization at BMC Software.
All right. Morning, everybody. Absolutely great to be here. I want to start by explaining why BMC is at a Hadoop show. And so what I would tell you is that our entire company is focusing on helping enterprise customers go digital. And go digital, creating these amazing customer experiences like you just heard about. And that requires an intersection of big data analytics, traditional IT systems, cloud computing, and mobile in many forms. And getting all that heterogeneous ecosystem to work well together is a big problem that we're trying to tackle with our customers. That's always what we've done, by the way, is tackling heterogeneous complexity and making IT more successful. The roots of the company actually go back, interestingly, to starting and helping optimize data management systems, particularly OLTP systems on the mainframe, which is still where about 70–80% of OLTP data sits today. And we're seeing interesting customer patterns as they try to use that mainframe data in whole new ways linked to big data. So Santander Bank, for example, uses our technology to export and automate about 6,000 Hadoop jobs every day from mainframe databases into their customer-facing cloud systems to drive higher levels of engagement. All right, so it's an example of bridging the traditional world and the new world using Hadoop and what we do. The other reason why we're here today is that we're hearing from all of our customers that this is the year where Hadoop is really going to become, hopefully, an absolutely critical part of their enterprise IT environment. And to be successful, those projects now is going to require us all to do some things differently. So I'm going to share a little bit of that with you today and hopefully make you more successful in the year to come. All right, so the lakes are big, they're also murky. I'm not going to rehash all the ways that data gets in there, how big it gets, but we know that once you start these projects, they're only going to get bigger and more complex. The more shocking stat that we have here is how little of that data is actually used and analyzed. And so if you're an enterprise CIO looking at this problem, I think there's two things that come to mind. One is, how can you increase the pace of innovation on top of that data so you're using what you have and what you're growing with and spending more money on in more innovative ways to help the business? And how do you run that really well? Because you're going to be spending money on this, so you got to run it well, and it's got to be really secure, since this is a lot of the crown jewels of information in your company. All right, so for us, the secret in winning and being the big fish in this big data and big lake ecosystem is going to be automation. So I'm going to share 3 ways that we're seeing customers do automation to be successful in their Hadoop projects. The first one is to innovate faster. So when you're in pilot phase, as we've heard this week, it's easy to use a variety of open source tools to schedule and automate your jobs, right? Could use any other technology that happens to be the latest. But when you're going to production, think of a traditional retailer who's trying to go digital. They have to take that Hadoop big data environment and integrate it to create digital experiences with traditional systems in ERP, logistics systems that might be running in the cloud, huge amounts of files that have to move around to process invoices. So there could be 20 or 30 different application environments and data repositories that have to be automated together to actually create those digital experiences. So what we've been doing is actually extending our job scheduling product. It's called Control M, one of the broadest used in the industry, to first of all make sure that we can automate across all those different kinds of applications and make it easy to integrate with new ones that come up every day. Also be the most comprehensive in automating all the big data technology, also which changes almost every day, but we're known as being the most comprehensive in automating those environments. And most importantly, the thing we introduced this week actually was now providing an API, JSON native API, to allow you to build all that powerful automation, not just for Hadoop, but across that enterprise application and data state right into your application. So what that means is now you can have simple, but very powerful code that takes advantage of Hadoop in this enterprise ecosystem and be more likely to be successful when you roll out the code for the first time. And we've actually seen this with a digital retailer we've been working with that has gone from the typical scenario when they're changing their job schedules across this complex environment. Initially, it took them about 3 weeks with an expert. Then we gave them a GUI to kind of do it with maybe a less technical savvy person that could optimize the jobs. It takes them about maybe 3 days or so. And then as we introduce this API to them, they can literally link this power right into their application in about 3 minutes and be constantly iterating and finding the best way to create that new digital experience. All right, so second way to automate and really be successful in this new world is to make sure you're managing scale. These lakes are only going to get bigger, they're going to get more expensive, and so there's going to be a heck of a lot more scrutiny on how much does it cost today and how is it going to cost me tomorrow. In fact, we just talked to a user on the floor yesterday who said their production rollout was stopped by their CIO because he didn't know, he wanted to know how much it was going to cost him both today, tomorrow, and 2 years from now. So what we've done is we've updated our capacity optimization technology to understand these big data environments and not only show you what you're spending today and all the underlying infrastructure for these Hadoop clusters, but actually use predictive modeling and data science to forecast where you're going to be over the next year, 2 years, et cetera. So you have much more clarity to get those projects approved and move forward with your CIO's approval. Right, so the last piece of automation that I think is critical for success is security. So think of these Hadoop clusters. They're running on increasingly dynamic, open infrastructure. It could be on the cloud, could be on-premise. A lot of open source in there. So it's guaranteed that hackers and all these black hat people are going to try to find a way to get underneath the infrastructure and into the data, which creates tremendous vulnerabilities. So it's going to be essential that you know in real time what the infrastructure is that is supporting your Hadoop cluster, what's connected to it, whether it's actually been scanned to be secure and up to date. And by the way, if there's vulnerabilities, and most of the vulnerabilities are actually known, that you're automatically remediating them on a constant process to make sure you have an ironclad environment that doesn't leave backdoors to get to your mission-critical data. All right? So this is the year that we think this is all going to go mainstream. To be mainstream, it has to be an integral part of the whole enterprise ecosystem. The business value and the promise is clearly there. But again, we think automation is key, both automating across the different applications and data in a very powerful way that you can build into your code, automating the understanding of what it costs to run it, both only today as well as tomorrow, and making sure the entire environment is secured and protected. Right? So I'm looking forward to being back here next year and hearing about all the amazing digital experiences and new business models you've all created with Hadoop. Great, thank you.
Thank you, Robin. Folks, go check out BMC Software, diamond sponsor of Hadoop Summit. Now let's welcome to stage Sita Chakrapani of Macy's Incorporated.
Good morning, everyone. So I'm back here again. You have been hearing a lot of use cases around retail. So I'm going to give you guys some more examples of how Macy's leverages big data solutions to drive our business. But before I get into the details, I wanted to give you guys a little bit more background about myself. So in the last 20 years or so of my career, I spent about a good portion, like more than 10 years in financial services industry, where I was tasked to go look at the data, analyze the data, and help homeowners during the worst real estate crisis that we just came out of. So the task there was to go look for homeowners that we can help so they can stay in their homes that they've lived in the last 10, 15 years so they don't have to move their entire family, and see if we can help them with their loans, if we can identify some opportunities to modify their loans so they can stay at their home. So that took 10 years of my career. And then I moved on to healthcare, where I was tasked to utilize data and analytics to help hospital operations, to help get insights for the doctors and nurses and hospital administrators to see if we can optimize that. So very satisfying experience coming out of those two industries. Then I wanted to do something a little bit more lighter. So I started looking at opportunities in the retail, especially in the e-commerce industry. Then I landed up at Macy's. So it's a very exciting space, exciting industry to be in. So let's get a little bit more background about Macy's. So I am assuming everyone in this room knows what Macy's does. So this is a 150-year-old company. There's tremendous legacy behind this company, and it's a very well-known brand in the country and also across the world. We are one of the nation's premier omni-channel retailers. Last year alone, we made $27 billion in sales. We operate over 870 stores in the country. We also have presence in the Middle East, and we ship products to over 100 countries. So, and since our business is seasonal in nature, we have fluctuating employees that come in. So towards holiday season, we hire up to like 150,000 employees to run the entire operations here. Let's focus to the digital side of Macy's next. So Macy's Digital is the 6th largest internet company in the country. Not a lot of folks know this. So we are big into the digital space. According to the benchmarking firm L2, Macy's is rated as #1 most digitally savvy retail departmental store in the country. In 2015, we expanded significantly. We invested heavily in our digital presence. We bolstered our site, and we aggressively spent on marketing. However, there is a major paradigm shift happening in the retail industry. This whole retail industry is in turmoil right now. If you look at same-store sales year over year, for going back last several years, it's been going down significantly every single year. In spite of the digital growth that we are seeing, which is about double-digit year over year, the growth from the digital side is not enough to compensate what we are losing on the store side of the organization. There is a paradigm shift of thinking coming our way. If you think about Macy's, for example, we have been operating on the offline side of the business for a long time. So you'll be getting direct mail from Macy's. You may see TV advertisements, radio advertisements, newspapers. All of those are offline marketing channels. But when the whole digital revolution happened, we went big on the digital side. So you may be a customer that you start your journey online, make your purchase online, or go to the store. So there's a tremendous shift happening in the way customers purchase their products, how they browse for our products, and the experience is shifting significantly. We need to put the customer at the center of every single decision that we take. It cannot be a technology-driven initiative. It cannot be something internal. It has to be all centered around our customer. Another differentiator for Macy's is that we have to connect emotionally to our customers, because for the most part, we are not in the business of selling to the needs of the customers, but we are selling to the wants of the customer. So that is a key differentiator. So you really need to connect to them at that level. And also, another important piece is that traditionally, retailers look at past purchase behavior and then try to predict what you're going to buy next. But the problem with that is you're not factoring in the life stages that the customer is going through. So you really need to look much farther into the history to see what life stage the customer is going through and stay relevant with them. But we are not done with that. So there's a major paradigm shift happening from the digital side of the business. So you may be a customer that just saw a TV advertisement. You're sitting on your couch, and you have a laptop, and you start searching online. You go to one of these search engines and start looking for the product. And at the end of the day, you might receive a marketing email from Macy's, and you click on that email. You go to the site. You do more research. You may decide to make a purchase there, or you may say, I'm going to wait until the weekend. I'll walk into the store, try it on, see if I like the color, if I like the texture of the product, and then make the call. So the picture that you see here is a very typical Macy's customer and the journey that they go through before they make the final purchase. It goes both ways. They may go to the store and then go home and make an online order, or they may start online and go to the store and make the purchase. We need to be able to understand how are we acquiring customers and how can we retain them for the long term. Because customer lifetime value is a very key factor for us. We need to be able to retain that customer and make them loyal to us. Now comes the challenge. So with this explosion in the digital economy, there's tremendous amount of data volume coming our way. So the traditional data architectures were not just designed to be able to accommodate this kind of data volume and variety coming, and they were not designed to quickly provide insights back to the business. And because this is a very drastically changing business, customer behavior is changing very, very fast. So if your solutions are not quick enough, you are going to miss the boat. And then we need to be able to scale to this volume. And at the end of the day, we need to be able to derive value from all of this. It's not just about the technology. I think you've been hearing this consistently from several of the speakers here. It's not just about putting together the technology piece, but how quickly can you derive value and prove that what you're doing is adding value to the business. So the solution, so we are going back 5 years. So when we started facing these challenges, the way we approach the solution here is, we started off with a small analytics sandbox. Let's pull this data in. Let's see if we can activate the analysts and data scientists, see they can pour over all of this data, get some insights, and inform the business about what strategy to move forward with. So from there, as we started pooling more and more data, the analysts and the data scientists and business users, they wanted to interact with the data through various tools. So what we had built is an ecosystem with big data and Hadoop at the center of this. So every tool that we deployed into the solution had to seamlessly integrate and cater to a comprehensive list of use cases. That's the most important piece. I think that's where you'll get the most value. A lot of companies, when they start the big data journey, they see this as a cheap storage solution. But that is the most simple form of use case that you can start with. But you need to get a lot more sophisticated than that. And what we have proved with our implementation is that a big data solution built like this can cater to not just ad hoc analysis, not just data scientists, but also traditional BI and reporting and dashboarding, text mining, all kinds of use cases can all be derived out of the same solution. So that is the beauty of the solution, that it's so flexible and extensible to cater to multiple types of use cases. And over time, as we derived value to the business, we were able to get the support from business and senior leadership to continue investing in this. And we built that momentum every year. So that's how we grew our solution. So the way we approach the solution is with this solution, we are able to look at the entire customer life stage attributes. When you come to retail industry, if you talk to the data scientists in the space, the number of predictors in retail industry is notorious. Like, we are talking about thousands of predictors. So if you need a solution that can ingest this kind of data volume. If you were to translate that into a single table, you're talking about a table with 4,000 columns. And that is extremely deep. Like, every single customer will have a row. And you're going to be scoring every single customer across all of these predictors every single day if you can. So a traditional solution, a data architectural solution, cannot cater to or solve to this. So you really need a big data type solution to be able to cater to that. You need to be able to bring in the entire web analytics data. Every single click that you go make on the Macy site gets tracked. And that data gets captured and sent back to Macy's. And this is a huge data volume to deal with. And you cannot go and say, this is too big. I cannot keep all of this in one place. I'm going to archive this, put it on a tape, and send this off-site. So that is just not feasible for the analysts. Analysts would like to see the entire data set so their models will be accurate. We need to be able to look at behavioral data, like how are customers reacting to some of the tests that we have going on the website. So we may be testing different layouts, different images, different formats. So we need to be able to measure the effectiveness of all the tests that we do and then get that data back so that we know what's the best way to design our website. Another thing that is important is because of all the variety of channels that we reach our customers, we spend millions and millions of dollars in marketing. So we need to be able to measure the effectiveness of our spend. And we need to monitor how often can we contact our customers? Is this the right optimal level? And most importantly, on the right side, what you see is the relationship that we have established with our vendors is really strategic in nature. There's very high levels of collaboration that happens between the product team, engineering team, and support teams, between our teams. So the vendors understand what we are up against, and they are in this together to come up with a solution. So looking at the future, everyone has been hearing about this explosion in data. I think we are only seeing the tip of the iceberg here. There's going to be more and more coming. But what is important is, can you get ahead of this? Can you manage this? Can you operationalize this data and derive business value? I think that's where the rubber meets the road. So you need to be thinking about what can you do ahead of time to prepare for this explosion and continuously add value to the business. So thank you. So that's our story.
Thank you,
Thank
Sita. Thank you for taking everyone through that. And your last comment about data explosion, I think, is dead on, right? It can either be a competitive advantage and people can embrace it and take advantage of it.
Absolutely.
Or candidly can probably get, fall behind the curve.
Exactly.
Yes,
Yeah.
so thank you. Thank you for doing that. And I want to also thank some of our last couple of speakers as well, right? All the other folks we had up there, Drew from Comcast, or BMC with Robin, or Carrie from EMC, and others. So we're coming up to the close, and I want to give you a view of some of what we heard over the last couple days, right? So one is we talked about customers transforming their business, and you got to hear from a whole set of companies in terms of what they're doing to transform their business, from retail to automotive to genomics research to others, and the types of things that they're doing as they're changing their business and leveraging the amount of data that's available. I want to thank all of them for participating and really spending the time sharing their stories with all of you, and hopefully you're able to go grab time and gather time with them, either at the end of the day, at the community showcase, at the party last night, or all the different places, because they're all very proud of their stories and very willing to talk about them. So I would encourage you, whether it was here today still, or even after it, to reach out and go share some of what's happening out there. We talked a lot about the connected data platforms, right, and what that means, and how there's data that can be running both on-premise and in the cloud, and how you ingest that data for data in motion, and what you do with data at rest, and how you aggregate all that together to get a composite picture of your customer or the other things you're trying to do as you're transforming your business. But the opportunity to do that is there, and we talked a lot about retail as an example of how do you use that to do predictive analytics, increase basket size, and leverage all the signals, all the different types of data that are available as you're looking to go form that picture of your customer or of the products in terms of what you're doing. Right? Number of announcements and a lot of interest in security and governance, right? How you do things like tag-based security, and how you start to go integrate what happens on the governance side and metadata management with the security side. And as Sanjay talked about, how do you now extend that into the cloud? And not just lift and shift what you do on enterprise into cloud, but really go build this in a cloud environment for the characteristics of the cloud and what you want in that environment. So a lot happening on security and governance, and obviously a continued investment in the community and in terms of what's happening. And I'll say lastly, heard about changing the world, right? A lot of what we're doing is not just transforming businesses and not just interesting use cases or saving money. In many cases, it's changing the world around what's happening out there. And DJ Patel talked about genomics research and the precision medicine initiative and what's happening there and how we can all change the world through harnessing the power of big data and what's out there. So I think it's important we all leave this thinking about the opportunity that we have in front of us and the opportunity and what we can do based on the data that's available. And I want to thank everybody in this audience, and I want to thank everybody next door in the community showcase, and really talk about the community, because in the end, it's about the community coming together to help build this technology, help drive the requirements, and then leverage this to go change their businesses and change what they're doing out there. And we're all part of this growing and thriving ecosystem. So part of what we're going to see going forward is we're going to extend this ecosystem out. So we've had these summits here, we've had them in Europe. Now we're extending to Asia with Melbourne, with Tokyo, and a number of other things that you're going to go see as the Hadoop Summit moves forward. But everything I've just described is where we've been in the past for the last 10 years, right? And how Hadoop has moved from large-scale MapReduce, batch analytics, to where we are today with streaming and IoT and ingestion of data and all the other use cases that are out there on predictive analytics, et cetera. There's much more that you can do beyond the original premise of what Hadoop and its components, right, were scaled to go do. So because of that, as we look at the next 10 years and say Hadoop Summit, we think Hadoop Summit also needs to continue to expand into its next generation, its second decade. So as we do that, Hadoop Summit going forward will now become DataWorks Summit. And the reason for that is we're talking about all data, all types of data, all classifications of data, all locations of data. So how do we start to bring all that together? And we thought the Hadoop Summit needs to expand as well. It needs to evolve to a DataWorks Summit. And as we do that, we'll start to have different tracks, right? A lot of what you heard today, and expand those tracks beyond just Hadoop and what's happening. And just to be very clear, Hadoop clearly doesn't go away. It's the foundation of everything that we're talking about. But now we can start having tracks and things talking about streaming and Internet of Things, right? What's happening around DevOps, production capability, how do you optimize your clusters, cloud, how do you run in the cloud, different tracks for people, both technology and business, as you want to participate on both the Hadoop side and all the surrounding projects in terms of how they can add value to what you're doing on your connected data platform. So with that, I'd like to close the formal part of the conference and welcome everyone to the rest of the sessions today. We'll certainly see you next year at DataWorks Summit in this same room in mid-June. Looking forward to all of you joining again, and also, again, having a lot of new people as we go forward. And between now and then, if you'd like to continue the conversation, please log into the Hortonworks Community Connection, a great way to go share information, go talk about what's happening, download code snippets, and really see what's happening in the community and get to participate in what's happening out there. So with that, thank you everyone for joining Hadoop Summit 2016. Please go enjoy the rest of the conference, and we'll see you back here next year. Thanks everyone, bye-bye.